How are you doing today?
I'm doing well.
Good. So, which teacher do you have, Bolton? I'm curious.
For math?
For your geometry course.
Well, I think Mr. Yansak's the only one who teaches honors geometry.
Yeah, unfortunately, that's what I've heard. I've had
Is he a bad teacher?
I've had lots of his students.
Is he a bad teacher?
Well, I don't know. I cannot answer that since I've never heard him teach. Naturally, when I get students that aren't doing well, their first tendency is to blame the teacher.
Oh, no. He's a good teacher. He's a very good teacher.
Well, good. I'm glad to hear that about him.
It's just they're disappointed in themselves that they're not doing well.
It's impossible for me to tell. You know, unless I get 10 straight students that complain about him being a bad teacher, then I maybe see a pattern, but I can't really make a judgment based on a couple of students.
He's very lenient.
Really? Okay. But he doesn't use your geometry book so much?
Only for homework.
Which chapter are you on? Are you on to chapter 2 yet?
Well, tonight's homework we had, I'm going to take it out, we had review. Tonight's homework was optional. It's optional, so we could get more points if we did it, which I'm certainly going to do.
Okay. You want to do some of those problems in our session today?
Sure.
What I need oh, it's probably in the book. I probably have the problems.
Page 60 through 63.
It might not be exactly the same pages because sometimes they...
okay. Chapter 1 review. Chapter 1 review.
Okay, good. I got it. And...
I got back my quiz results from Thursday.
Okay. And?
52 out of 52, I think.
Very good. Excellent. Okay, so chapter 1 review. What's the first problem you have?
So what we're doing is we're doing questions 1 through 35. So the first one would be vocabulary exercises. Copy and complete. Points A and B are in the blank of A, B.
Hold on a moment.
Wait, are the endpoints.
I'm looking in my book, seeing if I can find the similar... What's the first question again?
Okay, chapter 1, copy and complete. Points A and B are the blank of AB, of segment AB.
Okay, and so you know the answer, right?
Endpoints, right?
Okay, yeah. I'm not seeing that in my book. So, we have two choices. One, how many pages are you looking at? If you have to take a camera picture of it.
63. That's what I'm going to be working on.
How many?
60 through 63.
Can you take a picture of at least 60 and 61 and send it to me real quick, and we need to do this at some point in time. Might as well get it out of the way now. Let me write my email address that I want you to send it to. Don't send it to my phone, because then I have to forward it. It takes longer.
Okay.
And just send a couple, because if you send all 4, it'll take 5 minutes for it to get through the Gmail.
Can I text it to you?
I'd rather you send it to my email. You can text it. Well, you can't text to an email, can you? So it'd be better if you can share it to my email address. Because if you send it to my phone, I cannot bring it up on my computer. I've got to then forward it. Do you know how to send a picture to an email address?
Yes, I do, but I need to find Gmail.
Do you have?
I don't think I've actually.
I wrote the email on the screen, so you're looking at it. David Cowan, 1949 at gmail.com.
Okay.
And if you type it in once, that's the last time you'll have to fully type it in. In other words, the next time you type in DA.
It will be, it will be in the archives.
Right. Do you have an Apple phone or a Samsung?
I have a LG actually.
An old what?
An LG.
Oh, an LG. Ah, that's neither Samsung nor Apple, huh? That's a third different. What operating system do you use on that phone? Do you know?
I think it's like Marshmallow.
Huh. You might be the
I don't know.
Might be the first person I've met that has something other than an Apple or a Samsung. And Samsung uses Google software.
Okay, one more attachment. I'm taking pictures of all pages.
That's fine. Go ahead and do that. If you attach all 4 of them to the same email, it can take a while for that email to get here. So it might be better if you took one and send it, make sure that it works, and then we can send the other 3, and we can work on the one while the other 3 are being sent.
Okay. I just sent 2 pictures.
Okay. Let me pull up my email. I'll have a look. Which one do we want to open first? The one on the left or the one on the right? I can't tell. They look...
The top.
I'm sorry? Is it this one here? Ooh. You need to steady your hand when you take a picture of these. That's all I can say.
I know.
Let me have a look at the second one. Second one looks like the beginning one.
Yeah, that is.
Correct? Yeah. Question is, am I going to be able to make it out? I think maybe with your help, I probably could.
Okay.
But for the next 3 pages, why don't you take new pictures and keep the camera really still, and the light is everything. Notice how much better the one on the left is than the right. So everything about photography is about light, good lighting, and keeping it steady. Yeah, I don't seem to have this similar series of questions in my book. I'm looking at chapter review. Oh, I do have a vocabulary and vocabulary exercise. No, I don't have any vocabulary exercises in my book. Oh, so I see. So your first question with this was this copy and complete points A and B or the what of AB. Now, I cannot quite read these words, as you can see, right? You can see my screen?
I'm trying to take the pictures right now.
Okay. Make sure that you take pictures on the highest resolution.
I am.
You know, a lot of people that have Apple phones will send it as a small image, and that does not work. Have to send it as a large image. So if they give you that question, make sure you answer large image.
Okay. I took the pictures. No, I need to send them.
Send the first one only. Is it a remake of this first one? One we're looking at here?
No, I'm sending pages 60, 62, and 63.
That's fine. That's fine. I think I can make out this enough that we can talk about these questions also. So, what are points A and B of line segment AB?
Oh, crap. I sent an email with one picture.
It's okay. It's all right.
Okay. Then I'm going to send one with the other two.
Okay, I got here. What are your authors' name on this book? Is this Larson, Boswell, Stiff, and Canold?
Yes.
Okay. That's what I thought. I guess I might.
And it's the picture of that dude rock climbing.
Okay. Well, as long as I have this open, let's start here. So what's the answer to question 1?
Endpoint.
Okay. How would I, here, let me open, second, let me get this, snap left, snap right. So how would I draw a linear pair? Number 2.
Two opposite rays. Two opposite rays.
Yeah, or a way I like to think about it is I start with a horizontal line, and any line that is a straight line that intersects with that line creates two linear pairs.
Yep. And it has to have a point between. Oh, okay.
What's the relationship between 1 and 2?
That makes sense.
What are they called? 1 and 2 are called what?
Adjacent or supplementary.
Right. Both. They're definitely adjacent, but more importantly, they're supplementary. Linear angles are always supplementary. And it doesn't matter if there's 2 or 3. In other words, if I add a third angle, I also know that 1 plus 3 plus 2 is also equal to 180 degrees.
Yes, but wouldn't that be a linear triplet, right?
Yeah. I mean, I'm not sure it actually has names like that. The key is the bottom line. The key is this line here. In other words, it doesn't matter how many angles you have. I could have this many angles, and as long as this is a straight line, then the sum of all of those angles has to be 180 degrees. Again, the magic number in geometry is 180. Let me see if I can blow this up to a point where I can see 3 and the vocabulary, almost. If Q is between points P and R on that line segment PR, and PQ equals QR, then Q is the what of line segment PR?
I still have a question. Is Q equidistant from P and R?
Yes.
Okay, then it's the midpoint.
Correct. Correct. And that basically, when you ask that question, that was, is PQ, in other words, if I draw a line,
Is PQ congruent to RQ?
oops, Q is the midpoint, isn't it? Yeah.
Yes.
In other words, what this says is that PQ is equal to QR, correct? That's what that means,
Yes.
hash marks. And that means PQ is equal to QR, which means that Q
So hash marks mark congruency.
There's a very subtle difference between the words equal and congruent. Okay? When you're talking line segments, they're pretty much the same thing. When you're talking triangles, there's a little bit of difference. Let's talk about that. If I have this triangle here, and I have this triangle here, then I'm tempted to say that they're equal. But what if I have this triangle here, and I rotate it a little bit? Now, can you say those two are equal? No, but you can say they're congruent. So that's really the difference between congruency and equal. I could almost say that that triangle is equal to the other because it's in exactly the same position, it's got the same three angles, and it's got the same three side lengths. But these I cannot say are equal because this second triangle has been rotated.
You have to put that little squiggly line over it.
Yeah, congruent means that. And that's pretty much the difference. So when you're talking the difference between equal and congruent with line segments, I'm not sure there is any. In other words, if that's PQ and that's QR, those are both equal and congruent. Either term. They're trying to get you accustomed to this word congruent, which throws a lot of people off because it's just a different word. But it's not that different from equal, except when you start going to two-dimensional objects. In other words, when you have singular measurements, when we're talking about the measurement from P to Q, that's a single dimension measurement. Okay? But when we're talking about triangles being equal, well, what does that mean? That's at least two dimensions. And if we talk about solids, the same thing. So they introduced the word congruent to distinguish between just the size of everything. It's also its positioning and everything else like that. Okay, so that was 1, 2, and 3. Let's see if I can pull this up. Let's look at 4 through 8. Are you supposed to do every one of these, Bolton?
Yes. Yes.
Yeah, and I can read this now. I can actually tell where you had the lens of the camera. It was over the bottom part because this came in really clear and the top part not so much. Okay, so the best way to take pictures of problems in your book is to hold it maybe 8 to 12 inches away from the page, parallel to the page, in good
So that
light.
you can get it, yeah. So that you can get it enough away to where it's zoomed out enough, but not too zoomed out to where
Basically want the
undistinguishable.
center of the page to be in the center of your screen when you're looking at it. In other words, when you take a picture, you can see where the center of the page is. But most importantly is keep your camera parallel to the page. Don't have it at an angle. Because if you have it at an angle, you get distortion at one end or another. All right. Let's see. They are talking about this figure over here on the right. Give another name for line G.
Line XZ.
Good. Name 3 points that are not collinear.
Points X, P, and N.
Good. Name 4 points that are coplanar.
X, Y, and Z.
Name the intersection of line H and plane M.
You missed 7, question 7.
Name a pair of opposite rays.
Ray YX and ray YZ.
Okay. And name the intersection of a line H and plane M.
Wouldn't that be point Y?
Correct. Yeah.
Okay.
Looks like you're pretty good on these. We may not be the best way to spend our time. I certainly have similar problems that I can do. Now let's have a look at that before I go to those. I don't want to, just waste your time by doing stuff that you know how to do. Okay, let's look at 9.
Oh, that's easy. AB equals 1.2 units.
What's the equation you would write for number 9?
AB plus 2 equals 3.2 units.
Is that a 2 there?
Yes.
Okay.
BC equals 2.
I couldn't tell if that was a 2 or if that was a Z. Okay, so
sorry.
That's okay. So this is the picture. In other words, that's 2. And they're telling you that the whole thing is 3Z?
No, 3.2 units.
So the whole thing is 3.2.
Are you using like the other pictures I sent?
1.2. Okay. Is this one of them?
Yes.
Okay, let me pull those up. Maybe that will help. Much clearer. Much clearer, but not this same page. Here, let me look. Okay. This one here? Yeah. Yeah, that's quite a bit better, actually. What's NP in number 10? Hold on. There you go. These are pretty basic, aren't they?
These questions?
Yeah.
Again, it's an entire chapter 1 review.
Right.
So
Right.
we're also working on.
Let me just warn you that everything changes when you get to chapter 2. Okay.
Yeah.
Next week, we're going to want to work on chapter 2 because chapter 2 is where they get into proofs and logic. And
oh yeah, yeah.
That's where a lot of people start to have trouble, just because it's so different. At this point, like you said, it's mainly a review. What's the length of NP in number 10?
NP would have to be 30 units.
And XY in number 11?
XY would have to be 7 units.
Okay, let me look at 12 here. The endpoints of DE are minus 4 comma 11, and I didn't graph them on the XY plane. I should have, but that's okay. The endpoint of G and H, oh, okay, this is interesting. So here, well, let me graph these. Let me just do this. This maybe will teach me something about congruent.
I didn't need to graph them. I didn't need to graph them to realize that they're not congruent.
Okay. Why are they not congruent?
Well, we already know that they're not parallel, as
Correct.
if they were parallel.
One of the lines is a vertical line. That's D.
Yes. And one of them is horizontal.
Correct. In other words,
by mapping the difference between the y and the y values of points D and E, of segment D and E, I can get 24, the difference of 24. But mapping the coordinates, mapping the difference between the coordinates, the x coordinates of G and H, I only get 5.
What's the length of DE?
DE would have to be 24 units long.
The length of GH?
5 units.
Correct.
Therefore, they are not congruent.
I think that's the only thing you need for them to be congruent, is the same length. I don't think they have to be parallel. I could be mistaken there. It's been a while since I've studied congruency with just straight lines. You generally talk about congruency of straight lines. But my guess is that the only thing they have to be is the same length.
Well, if you think about it, two triangles that don't exactly have the same face, that don't, yeah, like you said, one may be facing different angles.
One may be...
but they'll have the same angles and sidelines.
Yeah, exactly.
They're still congruent.
Yes, exactly. Congruency does not require it to be oriented in space the same way. In other words, two triangles are congruent, but there's no way you would ever say that this side is parallel to this side and the hypotenuse is parallel to the hypotenuse. So I don't think being parallel or non-parallel has anything to do with number 12. I think the only thing that matters is the distance.
Okay.
I'm not sure where even to look that up. It's possible, I suppose, that distance and slope might matter, but I don't think so. I think distance is the only thing that determines whether line segments are congruent or not. Midpoint and distance formulas. These are actually pretty easy, as complicated as they look. I'm going to draw the first one, 14, just to show you why it's not as hard as it looks.
The midpoint formula is not hard.
No, the midpoint formula is very easy. But the distance formula tends to give people some trouble, and that's because they don't view it as they should. In other words, the distance between those 2 points is this long, complicated formula up here. But what is it really? It's the hypotenuse of that triangle, right? Still there, Bolton?
What?
The distance formula between A and B is always going to be the hypotenuse of a right triangle if you drew it. Correct?
Yes.
And this is the difference in the y-coordinates. This is the difference in the x-coordinates. So if you apply the Pythagorean theorem, then the hypotenuse, or the distance formula, always comes out to be the square root of delta x squared plus delta y squared, which is x2 minus x1 squared, that's what delta x means, plus y2 minus y1 squared. In other words, if you think of the distance formula as always being the hypotenuse of a right triangle, you will never forget the formula. Okay? In other words, here's the real distance formula. Well, I wrote it right there. But notice what that means. That's the difference between the x-coordinates squared plus the difference between the y-coordinates squared. And if I gave you a triangle to solve and gave you some sides, you'd be able to figure out the hypotenuse all day long by applying the equivalent of the distance formula. Okay. And like you said, the midpoint is just you add the two x-coordinate. What's the midpoint between these 2 points?
Of what?
Which
2 points?
Picture right there, A and B. What's the midpoint? What's this point right here?
The midpoint would be, the x value would be 3 and the y value would be 4.
Correct.
So it would be 3, 4.
Point halfway in between everything.
Yes.
Nothing exotic.
You have to add up the x coordinates and the 2 y coordinates and divide by 2.
Right, exactly. And you only need to do that if one of them is negative. In other words, as long as we have 4 positive numbers, you can do that in your head. What's halfway between 2 and 4 and what's halfway between 5 and 3. Now, if I put a negative sign on that, whoops, got it on eraser. If I say negative 4, now it's not so easy to figure out the midpoint. But the way to do it is you just add the 2 numbers and you divide by 2. Just like it says there. All right. Now let's see, we missed 13. Let's go back and have a look at 13. M is the midpoint between J and K. So here's J, here's K, here's M, and they're saying JM is 6x minus 7 and MK is 2x plus 3. How do I solve for x?
Wait, I screwed up. Okay.
Well, and that, it doesn't matter whether you're solving for x or jk. We have to solve for x first of all. What can I state about the jm and mk?
JM and MK are congruent, or equal.
Equal. I like equal better in this setting, which means I can write what kind of an equation?
So 2x plus 2 equals 6x minus 7.
Right.
2x plus 3
equals mk, then 6x minus 7 equals 2x plus 3. Solve for x? Always remember that algebra is at least 50% geometry.
So my first step would be to add the book out.
Give me the next line. I'll just write it. In other words, at this point of an algebraic equation, I usually do two steps in one. I move all the variables to one side and I move all the numbers to the other side. So what do you get when you do that?
Wait, what?
Move the variables to one side and move all the numbers to the other. Well, in this case, I'm going to move the 2x to the left and I'm going to move the 7 to the right. So what's the next line?
And you get 4x plus 10. 4x equals 10, sorry.
So x.
And then you divide both sides by 4 and I get x equals 2.5.
That's actually a better answer, believe it or not. It's the same as 2.5, but you'll discover as you go through geometry that ratios are actually better answers than decimal answers.
I know, but if you're trying to plug it into something else.
There's lots of reasons why. When you get to trig is all about ratios. Trig is not about 2.5. Trig is about 5 halves.
Yes.
And that kind of applies all the way up through calculus. So let's start getting used to giving our answers as a simplified ratio. So 5 halves. You're not going to lose points. If you put 2.5 down on a test, you get it right and you get full credit for it. But just between you and me, ratios are a better way to go.
Okay.
Okay, so tell me what the distance is on 14 between A and B. We know it's always square root of something, right?
Okay, okay, so the midpoint.
Not the midpoint, the distance. We'll get to the midpoint, but I'm going to do the harder one first.
Okay, what exactly is the distance formula? They didn't give it. They just gave numbers that they plugged into it. They didn't actually give the formula.
Here's exactly what it is. X sub 1 or X sub 2 minus X sub 1. And believe it or not, you can actually do these in either order.
Oh, yeah, I know.
Only because we're squaring it. And since we're squaring it, it doesn't matter if it's negative or not. So what's X sub 2 minus X sub 1 in 14?
So it would equal 2 or negative 2, plus or minus 2.
Well, correct. 2 or negative 2, we don't care which because we're going to square it. Okay, so that's the first part. What's the difference in the y coordinates?
And then 2 again.
Correct. Which gives you the square root of 8. There's your answer.
So 4 plus 4 equals 8.
Correct. And then you're taking the square root of 8, which is equal to the square root of 4 times the square root of 2, which is equal to 2 root
2 times 2.
Okay. Now, what's the midpoint between A and B?
Okay, then what you do is you, now it does matter which, no, it actually doesn't again.
No, it really doesn't.
It doesn't matter which one you go for.
You just need the halfway.
What do you call that? what do you call that?
Midpoint?
Theory or postulate? Where it doesn't matter which one you put.
Yeah, I don't think that's
It works with.
that's not really a theorem or a postulate. Here's the thing. The one place it does matter is in slope. Let's talk about slope for a moment. Slope is rise over run, right?
Yep.
That's what slope is. And I cannot reverse just either one of these, otherwise it gives me the opposite sign. But I could reverse both of them. In other words, if I do y minus y sub 2 over x sub 1 minus x sub 2, turns out that that's the same as that. It's exactly the same. You with me?
Mm-hmm.
Okay. But when we're talking distance formula, because we're going to square it.
What do you call that property? It's a property.
Well, I don't know what it is. I'm not sure what property you're looking for. It's not the associative. It's not the reflexive. I'm not positive that I know which property that is. Okay? I could mix them up if I'm doing this. When I'm doing the distance formula, it doesn't matter which one I put first because I'm squaring it. So x sub 1 minus x sub 2 squared is the same number as x sub 2 minus x sub 1. I'll give you an example. If I let x sub 2 be 3 and or x sub 1 be 3 and I let that be 5, well, the difference between those is, like you said, either plus or minus 2, depending on which way you go. But then when you square it, you always get 4. Doesn't matter whether it was plus 2 or minus 2. When you square it, it takes away the consequences of the sign. So that's why the distance formula doesn't really matter which way you go. And that's why I kind of like writing it this way, even though you might not see this in school. Delta x squared plus delta y squared. Delta means change. Means the change in x plus the change in y. And then it doesn't matter if you go x sub 1 minus x sub 2 or x sub 2 minus x sub 1. But make sure you do not confuse this with slope. Slope, it does matter which way you go. Mm-hmm. But with the distance formula, it does not matter.
Okay.
So, what was the midway point on 14?
3, 4.
Okay, how about 15? What's the distance?
Okay. So,
what do you always
25 plus 49.
What do you always start with when you're doing distance formula? That's what you always start with. Always the square root of something. Don't wait until the end to put that in there. Always start out with it. Now, what is it the square root of?
Okay, it is the square root of 5 or negative 5 squared plus 7.
Yeah, you don't need to worry about the plus or minus because it doesn't matter. Both of them squared are the same number. Plus 5 squared is 25, minus 5 squared is 25. So all you need is the distance between these two x coordinates. And you don't care if it's plus 5 or minus 5.
So doing that, I got 74.
Does that reduce?
Which would be reduced to?
In order to figure out whether we can reduce this, we have to factor 74. Factor 74 for me. There's the first two.
That's what I'm trying to do.
Okay, what's the next step? We know that 74 and 1 are two factors. Cut that in half and double that.
32 works, right? No, that's 60.
37 and 2, because 37 is half of 74. Then I discovered that 37 is prime. In other words, I cannot divide 37 by 2, by 3, by 5, by 6, by 7, any of those.
And so is 2. 2 is also prime.
Which means those are the only two factors of 74, and since one of them is not a perfect square number, that's simplified. Square root of 74 is as simplified as you're ever going to get. In other words, I could write it as square root of 37 times square root of 2, but that's two terms instead of one. So that's not simplified. So if you cannot pull a perfect square number out of that, it's simplified. Always. That's the definition pretty much. You've got to be able to pull an integer out of that. In other words, 76, that'd be different. 76 is divisible by 4. That's square root of 4 times square root of 19, which would be 2 root 19. So just that little difference between 74 and 76 makes all the difference in the world. Talk about factoring for a moment. Factor that for me.
So 54?
54? Yeah, factor 54. Always the first two you start with are that number and 1.
So 50, it would also be 27 and 2, and 27 is 3 squared, but that doesn't work.
But the next thing I would try to do is divide 27 by 2, and I can't do it. So the next thing I check is, can I divide it by 3? Ah, yes I can. Which means I have to multiply that by 3.
9 and 6.
Right. Now, can I do it again?
9 is a square.
Well, no, hold on. First of all, we want to know, can I divide that by 2? No. Can I divide it by 3? Yes. Which means I have to multiply 6 by 3. So I found 2 other factors. And that's as many as you're going to find. But the way you do these is you first try to divide them by 2, and then 3, and then 5. Not 4, because if it's not divisible by 2, it's not divisible by 4. So you go 2, 3, 5, 6, 7. That's the order. And usually by then, you've figured out that you're dealing with a prime number. Okay? That's my little technique. I don't know if that's what they teach you in school as to how to factor numbers. But that works pretty good, where you start trying to divide by 2, and then 3, and then 5. And usually that's all the further you have to go. You don't have to go much further than that. Okay, let's see. So we got the distance. What's the midpoint between F and G?
Okay, the midpoint would be 3.5, 3.5.
Okay. H, what's the distance between? But 16, right?
So it would be the square root of h squared plus the square root of 5 squared. No, it would be the square root of 8 squared plus 5 squared.
Right. Notice
So,
how much easier it is when you don't have to worry about the sign, right? In other words, you didn't have to worry about whether that was plus 8 or minus 8. All you knew was the distance between -3 and 5 was 8. And that's all you have to know.
so
64.
we get the square root of 89.
89. Is that simplified?
Is that a prime?
I believe it is. There's some cool number theory things that it's worth knowing. If a number is divisible by 9, its digits add up to 9. Very straightforward. 207 is divisible by 9 because 2 plus 0 plus 7 is divisible by 9. Okay? Good rule to know.
18. 1 plus 8 is divisible by 9.
18 is divisible by 9, too.
27.
This one is 17 is what I get, which is not divisible by 9. So this number is not divisible by 9. We know it's not divisible by any even number because it's an odd number. Now, a number is divisible by 3 if the sum of its digits equals a number divisible by 3. Okay? In other words,
yes. 17 is not divisible by 3.
Right. 123 is divisible by 3 because those add up to 6, and 6 is divisible by 3. So I know that's divisible by 3. So a lot of these rules are helpful when it comes time to whether or not you can simplify these things, because you don't want to pull out a calculator and start attempting to divide this by, every single digit number. It's not divisible by 5, clearly, or 3. 7, no, that doesn't work. Definitely not 8, because 8's even, and not 9. So that's got to be the answer. In other words, that's our final answer, square root of 89.
So then to do the midpoint formula,
What's
the midpoint formula
for that one, for 16?
So I get 1 and 6.5. 1 and 6.5.
1 comma 6.5. That's the midpoint.
Am I correct?
Uh-huh.
Okay.
All right, let's see. We only have 5 minutes to go. Let's not keep doing the same problems that you're doing fine on. Let's pick 18. It gets a little more complicated. Now, 18, it's going to be a little helpful if I draw a picture, and I'll show you why. There's point C. Which is 3 comma 8. I always approximate these because when you draw a picture, it's not necessary to be exact. You just don't need to be exact. What you need is just a general idea, okay? And they're saying that C is the midpoint of line AB. Well, they tell us where A is. A is over here at about there. So that's A, and they tell us that A is minus 1 comma 5. And so AB must be there, right? If C is the midpoint of AB. Now, in order to figure out what the coordinates of B are, it's a little different technique, but
yes, I do know how to do this. We went over this
easy. Yeah. What are the coordinates of B?
Well, here's my little way of doing it.
Okay.
I multiply the coordinates in C by 2, and then see what
Mm,
and then see what B would have to equal to get
here's
that.
here's maybe a better way. What do you have to do with the x coordinate to get from A to C? You have to go
You have to
right.
add B and divide by 2.
You have to go to the right by 4 units, right?
Yes.
In other words, to get from here to here, I got to go in this direction by 4 units. Well,
so then that would also mean you have to
go another 4 units in the same direction. And so what's the x coordinate of B?
7.
Do the same thing with the y coordinate.
11.
Because I had to go 3 units up. And so what I'm going to do is keep going that same number in the same direction. And that's how you got to 11. All right. That's a good place to end. That's good stuff. I'm quite sure that by next week we'll be in chapter 2.
Yep. We're probably going to be in chapter 2 by Friday.
Yeah.
We will be in chapter 2 by Friday because we're taking the exam on Thursday.
Okay, that's fine. We'll want to work on chapter 2 next week, for sure. Because that's going to be your first experience with deductive reasoning, proofs, all of the stuff that most people hate in geometry.
Well, I think I've learned enough theorems and postulates and properties to be able to do the basic stuff.
Okay, good. Good. The main things you need to, memorize are what the associative property is, what's the transitive property, what's the reflexive property, and then there's a whole bunch of stuff that they'll get into about conditional statements. If A is equal to B, is B necessarily equal to A? Or not equal? If P then Q, does that mean if Q then P? And the answer is no, it does not. In other words, if I say, if you live in Colorado, you live in the United States. But that does not mean that if you live in the United States, you necessarily
live in Colorado.
No, it doesn't. So
it does not work vice versa. It works one way, but it does not exactly work vice versa.
It's always true, and this is worth knowing. If P then Q always means if not Q, then not P. Think about our Colorado situation. If I do not live in the United States, that's the if not Q, then I do not live in Colorado. That's the not P. So if you have a statement, a logic statement that says if P then Q, the only thing you know for sure at that point in time is if not Q, then not P. But you certainly cannot say, now sometimes it's true that if Q, then P, but not always. Most of the time it isn't. In fact, that's one of the great fallacies that the human race suffers from, is believing that if P then Q means if Q then P. It does not. Anyway, I'm over our time. I will talk to you next week, Bolton, and I'll talk to your brother here in a minute. And I will text him his meeting ID number here in a moment. Bye-bye.